Welcome to our presentation. This video aims to show and make clear benefits of direct and continuous thermal compression through the VM system device modified compression solely to cell concessions of the patent Verdichtungsmodifikation. The rights for military use are reserved to the inventor. This product is an invention by Mr. Dionisio Hammes. It is internationally protected and it is registered in PCT Patent Cooperation Treaty. The business associate of this patent is a citizen of Bayern, Germany, Mr. Enno Schneiderbauer. The choice of aviation axial turbine was made due to its popularity, not its performance, since the modified compression drive device also works in other rotation engines for many different purposes. Nowadays, in order to launch a new product, besides its economic feasibility and its perfect functioning, social and environmental responsibilities are required from manufacturing process to use. This device is perfectly incorporated to this concept, as it reduces the weight and the number of components in rotation engines. Furthermore, it decreases pollution by increasing compression, which generates better and cleaner combustion. The VM system modified compression device, presented here in this turbine, is only one of many possible options, and it also shows the innovations included. The direct thermal compression of the modified compression device depends on its construction method, to be totally or partly thermal compression, when some previous stages of low pressure occur and/or a centrifugal stage occurs in order to increase airflow. In this case, the compression starts with the assistance of two previous low-pressure stages to feed the rotor major stage, which rotates between the internal and external closed blade walls, acting between low atmospheric pressure and high internal turbine pressure. Take a look at the architecture of this turbine in order to understand the way the device works. The passage of airflow between the low and high pressure areas with the least mechanical effort occurs by the interaction of all the components of the modified compression device. Mainly by the rotation of the rotor major stage between the closed blade walls incorporated to the combustion retainer, which separates the burning area of external air. In this case, the device has a round shape in order to facilitate the airflow. Modification of the compression. The separation of low-pressure atmospheric air from high-pressure gas within the turbine is done by the blade walls, between which the rotor major stage is located. The constant mechanical separation occurs whenever one or more transportation drawer-like blades have their edges simultaneously enveloped by both internal and external closed blade walls. That means that the drawer-like blades first make their way through the external openings, then they are completely shut between the closed blade walls. After this process, the drawer-like blades go to the active combustion high-pressure internal openings. Process demonstration. First, the inertial air inlet or low pressure into the rotor major stage compartment is performed by the openings in the external closed blades wall. Second, the feeding of low-pressure atmospheric air into the high-pressure turbine occurs by rotation of the rotor major stage, which transports air and/or gases in its drawer-like blades. The high pressure of the turbine does not make the rotor major stage rotation difficult, as the pressure works the inward and outward blades equally. Third, the pressure of combustion gases make the compression, while part of the gases flow over the low-pressure air during the exchange on the drawer-like blades of the rotor major stage, in order to introduce fresh air into the combustion retainer through the special openings with intervals in the internal closed blades wall. The exchange of fresh air by expanded gases stored in the combustion retainer is stimulated by the inertial speed of fluids and by centrifugal power. Most part of the gases from turbine combustion is available to generate motion energy. Fourth, the emission of gases used for the exchanges inside the major stage drawer-like blades occurs by residual pressure of hard expanded gases through openings on the internal closed blade walls and by the auxiliary exhausts coming out of the turbine. The discontinuous escape of residual pressure through the auxiliary exhaust brings low-pressure fresh air into the drawer-like blades, restarting the cycle. Simultaneous processing. The ongoing simultaneous processes of the constant direct thermal compression by the modified compression device require precise fuel injection with plenty of atmospheric air oxygen through accurate turbine rotation.